Hello students, welcome to the IMS Gate Academy. How are you all? So hoping that everything is good and whatever thing that you are going through with the content, with the preparation and all those things, you are up to the mark. Okay. So as you know that we had started a couple of days ago most expected concert and we have got the good response. So moving this forward, we had completed the electrical machine, which are basically common for the electrical as well as the IN stream. So I had taken almost around 13 lecture, 13 lecture, and we had discussed a quite challenging topic, quite interesting topic, and the important topic with respect to the GATE 24 exam. Not only for the GATE 24 exam, whatever exam you are having, those topic are very, very important. So moving the journey from the machine to the measurement. So we will going to start with the new subject, which is the electrical and electronic measurement. Yet it is again important for the EE and IN. Like if you see the overall marks with respect to the measurement, EE is having the marks variation between 2 to 4, whereas for the IN it is varying between the 3 to 6 to 7 depending on the GATE paper. Okay, all right. So guys, one request, please do like the session, please hit the like button, and also please share the session link with your friend, with your student, you can say the student community, over the Telegram, over the Facebook, wherever you are knowing the students or the basically the friends, I mean to say. Okay, and one more thing, please subscribe to our YouTube channel because it helps us to motivate and to bring such an initiative for you. So like we will be going to start with the important topic, which is basically the chapter 1, basics of error analysis. And in that we know that if you're going to see the past 10 to 12 year of question, at least you will going to have, or you are having at least one question from this particular topic, isn't it? So the importance of this topic is very, very high in the measurement. Whether you are from EE or IN, it hardly matters. It going to give you at least 1 marks in the GATE exam. Okay, all right. So guys, I need your support, so please do share the session link with your friend. So moving ahead with the topic, that is the tolerance or the limiting error. Like see, the tolerance or the error, like we know that to measure the voltage or current, we require the voltmeter and the ammeter respectively. So we know the ammeter and voltmeter are made up of physical element, isn't it? The resistor, the inductor, and so on and so forth. Okay, let me take an example like that. So if there is any variation in the voltmeter and if you are measuring any parameter, then definitely you are going to have an error in your measurand. So that error is specified in terms of tolerance, or you can say in terms of standard deviation. So there are two types of error in which we can denote the error of the measurand quantity. Measurand quantity means voltage and current, means the parameter which we are measuring is known as measurand quantity. Okay, so that thing we are going to find that how we will going to have the equivalent error for certain type of element. So let me take an example over here to understand it better. Suppose you are having an electrical circuit like this. Let me take a simple example or select simple electrical circuit. So this is plus minus 5 volt. Let me take this as 3 ohm and this as 2 ohm. And across this 2 ohm, I need to measure the voltage. So let me connect the voltmeter. We know to measure the voltage, what we require? We require the voltmeter, isn't it? So this is your voltmeter, and if you want to measure the voltage across this 2 ohm resistor, so definitely whatever voltage is coming over here, it will be going to indicated by your voltmeter. So ideally, what is the voltage here, my friend? Let me take plus minus V naught. So V naught is applying voltage division rule, 5 into 2 divided by sum, which is 5. So this is equal to 2 volt. So this is known as true value of the voltage or the output voltage. But we know that the voltmeter are made up of physical component, and since this is a voltmeter, so the internal resistance of the voltmeter, this is very important point, the internal resistance of the voltmeter are very, very high. Whenever if you are going to design the voltmeter, then internal resistance will have to be high, and in the same way the ammeter is designed for a low value of resistance. Why we are designing the voltmeter to be on a high resistance side and ammeter on a low resistance side? Amit Goyal, good evening. Good evening, Amit. So, Amit, please do share the session with your friend. Okay, all right. So, see, so as I told you, this is very important. If you want to design your voltmeter and ammeter, then for voltmeter, you require high value of internal resistance for the voltmeter, and in the same way for ammeter, it has to be a low value of resistance. Okay? Okay. So, this is a true value. But as I told you, this is a practical voltmeter, so definitely your measured value V naught M, this may be less than 2 volt, or it may be like greater than 2 volt. Anything can be possible depending on the voltmeter. Okay? So this 2 volt or this measurement quantity, how we can denote, is known as your notation of the measurement parameter. Got the point? And if you see, this is your true value, and let me take an example. V naught measured, if it is coming as, let me take an example, 1.5 volt. Like we know, it is not practically like it is not always true, but let me take for a simple manner. So if you find that error over here, E, which is equal to, or percentage error which is equal, percentage error equal to V measured minus V true, or let me take V naught M minus V naught true divided by V naught true. So what is V naught M? This is 1.5. I have taken only example. Do not think that how it comes. ठीक है, मैं खाली general purpose के मैंने लिया है वहाँ पे. So 1.5 volt minus true value is 2 divided by 2 into 100%. So what value is coming here? This is minus 0.5 divided by 2 into 100%. So this is minus 0.25 into 100%, and this is equal to minus 25%. So this minus 25% is what? Error. Got the point? So since I have taken V naught M less than, it can be greater than. So if you take the value like 2.5 volt, then error will become positive. So ये value को आप ध्यान से देखो. This is known as your tolerance or limiting error. तो समझ में आ गया tolerance और limiting error का मतलब क्या है? The deviation of the measured quantity from the true value. Measured quantity from the true value is known as your tolerance or error. If the error is specified in terms of percentage, then it is known as your tolerance or limiting error. ठीक है? चलो. But what if, since here we are having only one source or the one source of parameter which are giving the error over here. ठीक है? तो assume करो if you are having n number of element. So let me take an example. Your boiler plant. This is boiler plant. Okay. So in the boiler plant, what is going to be happen? Its task is to provide some or a chemical plant. Let me take, it is better to write chemical plant. Chemical plant. Okay. So in the chemical plant, what I usually want to have? I want to have the chemical over here. Okay. Okay. So let me take ethanol. So you are having a one process plant which is generating the ethanol. Now for that, this is output. So for that, you require input. So let me take, you are having input 1, input 2 and input 3. And this input is going to be processed under the process control. So let me take the element 1. Let me take element 2. Let me take element 3 and so on so forth. Let me take till element n. So all elements are interconnected. ठीक है, all element are interconnected. So after the processing it will going to produce an ethanol. So if I want to know what could be the possible value of error in the ethanol if you are having only one element which are generating the error, what I mean to say, suppose this error is plus minus 5%, so definitely this ethanol will going to have plus minus 5% of error in the output. Then assume that this element 2 is having plus minus 2% of error. Then what will be the possible or the equivalent error for the output? It can be plus minus 7%, it can be anything. So what we have understood from here is if you are having an element more than one, then it is not possible to find the equivalent error very easily. So for that we need to study the different approach which is known as the tolerance approach or the tolerance analysis. Got the point? तो यही चीज हम लोग देखने वाले हैं कि if you are having the n element and all the n element are having their equivalent error, then what would be the possible value of error in the equivalent quantity. ठीक है, समझ में आया? कोई डाउट यार यहां पे? ओके, चलो. So just a second. Let me take the margin over here. Let the function f of x, let me take this as capital X, is a function of independent variable as given, or independent variable x1, better to write x1, x2, x3 and so on so forth till xn. So the element which we are having here, this I have denoted as x1, x2, x3 and so on so forth till xn. Okay. So let x1, x2, x3 so on till xn are having true value as x1t, x2t, x3t and so on till xnt, and also they are having the individual tolerance or error as del x1, del x2, del x3, so on so forth till del xn. ठीक है? So see what I mean to say, this output voltage यहाँ पे हमने लिखा था ना V0. See, this V0 is represented as V0 true plus minus del V0. So true value is what? 2 volt. Done. And this error, like if you see what is error over here, this error is minus, like in volt na, this is what? Minus 0.5 volt. So this can be plus minus 0.5 volt depending on the V0 m value. As I told you, this can be positive or this can be this can be greater than true value or this can be less than true value. So according to that you are going to have your error which can be positive or negative. Okay, so this is your V0, how we are going to represent. So this is nothing but your x1, this is x1 true plus minus del x1. I hope you are getting me. मैं क्या कहना चाह रहा हूं आपको समझ में आ रहा होगा. ठीक है, चलो, taking this further. So this implies your x1 which is equal to x1 true plus minus del x1. Similarly x2, this is equal to x2 true plus minus del x2 and so on so forth till xn. xn true plus minus del xn. So this value are represented in absolute term. Okay, what do you mean by absolute term? If the error is having any unit, suppose this is voltage, then this is also going to be voltage, this is also going to be voltage. So if this del x1 is in unit, then it is known as absolute, like this thing is represented in the form of absolute term. Now another thing that we can represent this x1 in the percentage. How? See. So this x1, or let me write here first, note, error can further be denoted as relative term. Okay, see, if x1 which is equal to x1 true plus minus percentage del x1, since you have used the percentage, so this is in relative term. Similarly, x2 which is equal to x2 true plus minus percentage del x2, and so on so forth till xn which is equal to xn true plus minus percentage del xn. Just a second. Okay. So where x1 is, where percentage del x1, this is what? Error in x1 element divided by true value of x1 into 100%. Similarly, percentage del x2, this is equal to error in x2 element divided by x2 का true value into 100%. And similarly, so on so forth. Just a second. So percentage del x3 which is equal to del x3 whole divided by x3 true into 100%, and at last percentage del xn, this is equal to del xn divided by xn true into 100%. ठीक है, any doubt till this point? So if this is represented in terms of percentage, then it is said to be relative term. And if it is represented, error if it is represented in the unit, then it is known as absolute term. So depending on the units, our formula is going to be utilized. So see, then the equivalent error in x or f of x is given by, this is very important, please look at the word very carefully. So the equivalent error is given by, so del x, this is the error in the function which is equal to partial derivative of x function f of x, or simply capital X, with respect to first variable, and the other variable is are constant, into error in x1, and take the mode like this. कोई डाउट यहाँ पे? Similarly, let us take the next independent variable. Then the remaining will be constant. Since you have taken x2, so x1, x3 and so on and so forth are constant here. Okay, all right. So this is error in del x2 and take the mode and so on and so forth till last one. So del capital X del xn into, sorry, here others are constant, which is x1, x2 till xn minus 1. So these are constant and error in xn. So, and last mod. Okay, just a second. Let me have a space here. Okay. And plus minus. So this formula is very, very important if you are having any question, any question related to your tolerance. Okay. ध्यान से देख ले इस फॉर्मूले को. Here we have used the mode. Okay, these all are mode and we are doing the partial derivative of the equivalent function with respect to all independent variable, which is x1, x2 and so on and so forth. Partial derivative means the other remaining very independent variable are taken as a constant. जैसे कि आपको यहाँ पे दिख रहा होगा, x1 से किया तो बाकी constant है, x2 से किया तो बाकी constant है, and similarly xn से किया तो बाकी constant है. Okay, so in this manner your error x true is denoted, f of x or capital X, this is represented in terms of true and in terms of your error. So which is equal to x true plus minus del x, which is this one. Done. And this is in absolute term. This can also be represented in percentage, which is equal to x true plus minus percentage del x. ठीक है. So ये error हमें find करनी थी. What is percentage del x and how to get this value percentage del x? So where percentage del x is, let me write here, where percentage del x is error in x, which is this value, divided by true value into 100%. Done. And at last, just a second. And at last, just a second, we are going to have the true value. And how to find the true value? Just a second, my friend. Let me shift it somewhat upward. Okay. So how to get the true value? How to get the true value? Where x true, this is equal to function of x1 true, x2 true, and so on so forth till xn true. ठीक है. Do not get worry we will going to take a gate problem, and from there we will going to understand this particular theory portion. Okay, do not get worried, but you need to understand how the basics are here, like how we are going to have the values of the equivalent parameters. So you are going to use this formula, and at last, depending on the unknown parameter, like whether the gate faculty are asking the question or the answer basically with respect to the unit or with respect to percentage error, that we need to understand. Like depending on the equivalent parameter, depending on the how they have asked the answer, basically on that we are going to use this two particular formula. Okay. So this is all about the tolerance or the limiting error. Now let us discuss this thing with the gate problem, and from there I am 100% sure you are going to grasp all the concepts. Okay. So this is the first problem which we are having. The two resistors R1 and R2 can be connected in parallel. They are having the values as R1 equal to 100 plus minus 0.1 ohm and R2 equal to 50 ohm plus minus 0.05 ohm. Find percentage error in the equivalent resistor. Okay. So if you see carefully, R1 and R2 are connected in parallel. So let me take the parallel connection like this. This is R1 and this is R2. Okay. R1 is 100 ohm. This is 100 ohm plus minus 0.1 ohm, and R2 is, this is equal to 50 ohm plus minus 0.05 ohm. So since these are connected in parallel, so let me take the equivalent resistor as R. समझ में आ गया? The equivalent resistance is R. So R1 which is equal to 100 ohm plus minus 0.1 ohm, and similarly R2 which is equal to 50 ohm plus minus 0.05 ohm. So this is represented in absolute or relative. This is represented in absolute. How? The error is specified in unit. So this is equal to R1 true plus minus del R1. Similarly, this is your R2 true plus minus del R2. Done. So what is parallel combination? R which is equal to R1 parallel with R2, and this is equal to R1 into R2 divided by R1 plus R2. This is how we write the parallel equivalent, isn't it? ऐसे ही लिखते हैं, कोई डाउट इस पे? क्लियर है? Now how to get the equivalent error? So equivalent error which is represented by del R, this is equal to plus minus. How many independent variable we are having? We are having two. So we will have to differentiate the equivalent R with respect to two independent variable, keeping others constant. So कैसे होगा? Del R with first variable del R1 into error in del R1 and take the mod. So here R2 is constant plus partial derivative of equivalent resistor R with respect to second resistor, and here, sorry, okay, wait a second, here I need to shift. Here this is constant basically. Here R2 equal to constant and error in del R1 and take the mod. This is mod. Okay, similarly del R with respect to del R2, and here R1 will be constant, isn't it? R1 equal to constant into del R2 and take the mod. Okay, so in this manner we are going to get our equivalent error. So since Del r by del r1, let us differentiate this one keeping r2 as constant. तो क्या होगा जल्दी देखें. Del with respect to r1, r is what? r1, r2 upon r1 plus r2. So here r2 is constant, here r2 is constant, so take this to outside. So we'll get r2 partial derivative of r1 upon r1 plus r2. Done. So this is basically your u by v form. So how to get the derivative? This is r2, let me write it outside, this is r2. So how to get the derivative? So left denominator r1 plus r2, differentiate numerator, minus left numerator and differentiate denominator with respect to r1. So this will be 1 plus, since this is independent, so it will be 0. Differentiation of independent variable is what? 0. And whole divided by denominator ka square, r1 plus r2 ka whole square. So when you simplify this, we will going to get r2 times, here r1 plus r2, here minus r1. So it will be cancelled out, r1 will be cancelled out. So here r2 upon r1 plus r2 ka whole square. So if you see here carefully, the partial derivative is giving you the equivalent expression as r2 upon r1 plus r2 ka whole square. And this is very important. Like those who want to save the time in the GATE exam, you can directly remember the equivalent derivative expression with respect to r1 as this value. Because 99% time you are going to have the question with respect to parallel combination if you are having any question from the tolerance. Okay. So if you want to save the time, you can directly remember this particular derivative. Done. So this del r by del r1 is this value. Similarly, del r with respect to second variable, which is r2, and here r1 is constant. So this is equal to del with del r2, r1 by r2 upon r1 plus r2. So when you differentiate this, like doing the same thing but with respect to r2, now you are going to get, see here you have differentiated with r1, then in the numerator we have got r2. So if you are differentiating with r2 in the numerator, you will get r1, opposite of that, and denominator will be r1 plus r2. Okay, otherwise you can cross check by differentiating. Like if you want to know how it comes, you can differentiate this. Okay. So my dear friend, how to get this value del r by del r1? So del r with respect to del r1, when r2 was constant, this value was r2 upon r1 plus r2 का whole square. So this is your true value. This all are the true value. So true value क्या है r2 का? r2 का 50 है and sum is what? 150. r2 का 50 है and sum is 150 whole square. So this is 1 by 3 का square, which is 1 by 9. Okay. In the same way, del r by del r2 when r1 is constant. So this is equal to r1 upon r1 plus r2 का whole square. So r1 was 100 and sum is 150 का whole square. This is equal to 2 by 3, or take the square, you will get 4 by 9. Done. So the equivalent error del r, which is equal to plus minus, substitute the value. This is 1 by 9 into error in r1. इस फॉर्मूले पे सब्स्टिट्यूट कर रहे हैं. व्हाट इज द एरर इन R1? R1 एरर इज 0.1, है ना, 0.1. And take the mode plus 4 by 9 into 0.05. This is del R2 which is 0.05. जरा देखो तो क्या आ रहा है. 4 into 0.05 means 0.2. 0.2 plus 0.1. 0.3 by 9 ohm plus minus 0.3 by 9 ohm. ठीक है. So which is equal to 1 by 3. 1 by 3 is 0.33 divided by 10, 0.033 ohm. ठीक है. 0.3 divided by 9 is what? 0.033 ohm. But we need to find in terms of percentage. So for that we should write the formula. What is percentage del R? This is equal to error in R whole divided by R true into 100%. So this is your del R. How to get R true? R true is equal to parallel combination is R1 into R2 na. So take the true value of individual. R true upon R1 true plus R2 true. So ये value कितना आएगा? R1 is 100, R2 is 50. Take the sum which is 150. So this is equal to 100 by 3. 100 by 3 ohm. But we need to find in percentage. Okay. So substitute here. This implies percentage del R. This is equal to plus minus. This is 0.3 by 9. 0.3 by 9 into 100 by 3 ना. 100 by 3 into 100%. जरा देखिए क्या आ रहा है, प्लस माइनस. सो इट विल बी 0.9 by 9 है कि नहीं. 0.9 by 9 and this 100 will be cancelled out. So this will be equal to plus minus 0.1%. जरा चेक करेंगे सर, we are getting the same value or not. So if you simplify this, you will going to get the percentage del R as 0.1%. Any doubt? So this is the error in terms of absolute manner and this is the error in terms of relative manner. So you will be very whenever you are having question, please be careful about the units, whether they are asking in percentage or whether they are asking in the unit or not. So similarly your value is going to be changed. So the correct answer is 0.1. So answer is 0.1%. Okay, I hope it is asking percentage. ठीक है. Now we are having one more question which was asked in GATE 2015, which is this one. Okay. So since we had discussed the concept, we have seen all the things. So let me give this particular question as a homework question. Okay, and I want each and everyone who are currently present over here and those who are going to watch later, please try to solve this particular question and give the answer in the comment box. Definitely whenever I will get the time, I will going to see all the comments, and if there are any correction in the answer, I will going to rectify in the comment box itself. ठीक है. So please answer करिएगा, जो भी आंसर आपका आ रहा है comment box में. ऐसा नहीं कि since it is a GATE 2015 question, let us see the solution and after that we will come here and we will post in the comment box. Okay. Sorry for the PJ. So yeah, I know my students are very sincere and serious, and they are here to learn the concept. Okay, that I know. So please do attempt this particular question and try to give your answer in the comment box. Okay. So with this we have completed the one topic, which is the your tolerance or the limiting error from the measurement. So we have completed almost, or you can say not almost, at least 1 mark of question from the EE and IN. So guys, please hit the like button if you have liked the session, and also please share the session with your friend, and also please do inform that an excellent series is going on the IMS YouTube channel, so that they may also come and join the live session as well as, and even if they are not able to join for so-called reason, please share the session with your friend, so that they also may going to get the benefit of from this particular session. Okay, and also please do subscribe our YouTube channel if you have not yet subscribed, and also please press the bell icon, which is very important, otherwise you will not going to notified instantly. Okay, so see you in the next lecture, which is on tomorrow, and we'll see the next important topic. So bye bye, and take a very good care of your health.